So I've put the word fracking in inverted commas because it's a word I don't normally use, but I think the organisers suggested a title. The reason I don't like using it is it's very emotive, I'm sure you know, but fracking or hydraulic fracturing is just a part of the process of shale gas exploration and development. Environmental risks associated with it go beyond just the hydraulic fracturing stage. But anyway, so what I'd like to do first of all is just acknowledge a number of partners, a considerable number of partners who've been working with BGS on this issue, in particular in relation to a collaborative environmental monitoring programme that we established just over 5 years ago, including Public Health England, and I've known Robbie probably for 5 or 6 years when the topic started to emerge. As I'm sure you're all aware, it has been a very emotive subject, fracking or hydraulic fracturing and shale gas development in the UK, and obviously there are moratoria which now extend across the whole of the UK, but until recently England was the only place where shale gas development was taking place. Now, for those who are less familiar with shale gas and the extent of it, on the left there is a map showing a very simple geological map, and the areas that are coloured in the yellow, blue, pinks and so on are the areas of the country or the UK which are underlain by shale. Now, shale is an organic rich marine deposit laid down as a sediment hundreds of millions of years ago, and where it's been buried to considerable depth, and by considerable depth I mean several kilometres, over hundreds of millions of years, that organic material is transformed into oil and or gas, and hence that rock contains the hydrocarbon which has been the target for exploration companies. What you can see is some of the areas highlighted there are where BGS has undertaken resource estimate studies for government to assess the potential for shale gas. But what we didn't have is good data, or anybody had good data on whether the gas in the subsurface or the oil was extractable. And so the companies have since been looking at applying for licenses and undertaking exploration work. On the right, just to highlight the north of England, which is perhaps the area which has got the most promising, if you like, areas or potential for shale gas, BGS identified two particular geological horizons in the subsurface which are potentially productive. And on the bottom right there, you can see one is green and one is orange. The green is a sort of very thin, laterally extensive layer, but the orange one is much more less laterally extensive, but is much deeper. And the difference between the UK and the US, for example, is in the US, most of the shale there is very thin, but very laterally extensive, a bit like the green. In the UK, we've got very, very deep shales, the deeper on the orange one, which extend to maybe 5 kilometres in thickness. So potentially there is a significant amount of gas and or oil present in the subsurface. So just a little bit of background to that. As the industry started to look at the potential for it and start to think about where monitoring, where to undertake the exploration, BGS, we sort of at the early stages, we could see the challenges in the United States, the allegations of pollution of water supplies, drinking water sources, and other environmental impacts. And it was very controversial because there was not good evidence of what the environmental conditions were, or the baseline was, before the industry went ahead. And in the United States and North America, it developed very, very rapidly. And so we undertook, firstly, a national survey looking at methane and groundwater, but then increasingly localised those studies and started to focus on the areas that were being considered for exploration. And we moved beyond groundwater to include a whole range of environmental compartments, if you like, that were of concern with respect to potential environmental impacts. And that included surface water, groundwater, air quality, the risk from seismic activity, ground motion in terms of subsidence and uplift that may be caused by the operations, soil gas in terms of a potential pathway to the surface, and radon in air. So working with our partners, we brought together the expertise needed to monitor the range of environmental compartments in relation to the risks associated with the potential risks. And the focus on this was to produce a very high quality data set that initially was to characterise the baseline before the industry proceeded. We had no control of how rapidly it proceeded, or indeed if it did. And so we needed to get the best available data. And that data was very much focused on providing information to inform the public because of the concern that they had around the industry, also the industry itself, because it was having to undertake monitoring or think about monitoring in relation to what the regulator required, and indeed the regulator itself, because it was a new industry to the UK and to England. So what type of monitoring was required in terms of characterising the environment and then looking at potential impacts. And so we undertook this. It's about creating a monitoring programme that was looking at development of new technologies. Can we apply existing technologies and modify those suitably? Do we need new technologies, new sensors? And bring that all together in a coherent way that helped us be prepared for an industry that might develop. So we focused on two areas. Firstly, in Lancashire, the Fylde area of Lancashire, where Quadrilla was starting to explore for shale gas, and also in North Yorkshire in the Vale of Pickering, the other side of the Pennines, different geological setting, and again, another company called Third Energy who were thinking about developing shale gas. And both companies were racing themselves neck and neck to get the permissions in place to carry out hydraulic fracturing first. So here you can see the water quality monitoring network that we put in place, a combination of existing monitoring infrastructure, private supplies, public water supplies, Environment Agency monitoring network, plus we supplemented that with new monitoring facilities as well, new boreholes drilled. And we monitored a wide range of environmental parameters. Many of those are potential indicators of change, which could indicate the impact of shale gas, but also we needed to characterise the environment as well. So we wanted to make sure we understood the natural or the baseline quality of groundwater. That included both inorganic and organic substances, dissolved gases, particularly methane, obviously as the source of the target for the companies, and being very buoyant, it could very rapidly reach the surface. So dissolved gases, and also concerns about the emissions of radon, release of radon, so looking at naturally occurring radioactive materials in groundwater. So a wide range of contaminants, pollutants, parameters we were looking at. And this is just showing the Vale of Pickering. So one of the things that took us very significantly by surprise was when we monitored the shallow groundwater, we found extremely high concentrations of methane. Bear in mind this was before any permissions had been given for shale gas development. So concentrations up to 40 milligrams per litre. If I tell you that the action level or the concern level in the United States is 10 milligrams per litre, and if you reach 28 milligrams per litre, you can have concentrations that in an enclosed space would lead to an atmosphere that's explosive. That's quite concerning. So where is it coming from? Well, in short, it's basically coming from the underlying geological formations produced in the shallow subsurface, not by the process that I explained earlier on, but actually by the production of methane by bacteria. So microbiological production of methane in the shallow subsurface, generating concentrations like that. So if we hadn't collected those data before the industry went ahead, industry started, monitored that, what would people think? So again, very important we understood the baseline, and this has actually triggered a considerable amount of research since, and NERC and ESRC are funding BGS and some of those other partners to actually look at the processes controlling the emissions of methane. Because very high concentrations like this, shallow groundwater, where is it going? Probably being released to the atmosphere. So what is the contribution from shallow groundwater to global methane contributions? And again, just looking at another parameter, which is perhaps an indicator of you'd look for in terms of impact from shale gas. Here we're looking at the Lancashire Fylde, and on the top we have the data are all for chloride, so salinity effectively. The top data are BGS data, the data at the bottom are Quadrilla. So we've got, and if you can just see the highlighted area, it doesn't work, but perhaps you can just see the bar under where it says HF1Z, is the period when they carried out hydraulic fracturing. And so, certainly for groundwater, we saw no changes in groundwater quality in relation to the hydraulic fracturing activities on the site. And these were monitoring sites actually adjacent to the shale gas well. Moving on to seismicity, and I'm sure you're aware that reported earthquakes attributed to the shale gas activities and the hydraulic fracturing. Again, I apologise for the sort of clarity of these, but again, on the top left, it shows that we introduced or put in place a dense network, a relatively dense network of seismometers and we were able to monitor the industrial activity as it proceeded. The bottom left shows just an example of how the seismometers pick up the seismic events as they occurred during hydraulic fracturing. And we report all of those onto the BGS website as a catalogue of events and provide a commentary on what those observations mean to the public. Now here's perhaps a more detailed map of how that induced seismicity emerged as Quadrilla carried out its hydraulic fracturing. So the blue stepped line reflects the volume of fluid injected during hydraulic fracturing. The steps reflect the different stages of hydraulic fracturing. The bars show you the induced seismicity which occurred. So there's a clear correlation between when they carried out a fracking event and when the seismicity occurred. But then there are also what we call trailing events afterwards. So the top two are when they fractured their first well. There were two periods of hydraulic fracturing. The bottom is when they fractured their second well during last year, during August. And on the 26th of August, they triggered a 2.9 magnitude event which brought proceedings completely to a standstill. And then ultimately operations were suspended, and a report and review of that led to then the government making a decision for a moratorium. That 2.9 magnitude event was not detected by Quadrilla's seismic array because they were changing the computer over because they'd run out of memory on their computer. The monitoring I showed you earlier, the BGS monitoring, was the monitoring that detected that event. Now moving on to air quality, developing through here. Again, we've monitored at a fixed station down prevailing wind, a broad range of air quality parameters, including some of those we heard about earlier, greenhouse gases and a range of health-related air quality parameters. And you can see at the top methane and CO2, and you see that is effectively a background, the observed background. You can see there's a lower level which reflects when, in this case it's Lancashire, when the wind is blowing off the Irish Sea, nice clean air, low background. The spikes reflect when the wind is blowing from other sources on land. The prevailing wind direction in the right shows it's from the west. During monitoring, whilst operations are taking place, we observed something unusual in the January of 2019. So after hydraulic fracturing had finished, but the operator was carrying out what they call well testing to calculate how much gas they could get out of the well during that period of January. And we detected a very strange anomaly in the monitoring data where we saw relatively high concentrations of methane, but not equivalent CO2. And the wind was blowing directly from across the site. And that indicated to us that there was a new emission source, and it was coming from in the direction of the site. What we found out from the operator was that at that time they carried out a process of lifting the fluid that was contained in their very deep well, and it's about 2.5 kilometres deep, so you have a 2.5 kilometre long pipe full of fluid. They needed to get that fluid out to let the gas flow. And the way they do that is they they put a hose down to the bottom, pipe down to the bottom, and then inject nitrogen to lift the fluid up to the surface. So they lift the fluid out, nitrogen comes back, mixed with methane. The environmental permit required them to flare that methane. They put that gas, nitrogen and methane, into the flare stack. There was one ingredient missing, of course. That's oxygen. So it didn't burn, it went up into the air, and that's what we were detecting. So how confident were we that it was that? Here you can see the wind roses for the 3 years, January 2017, January 2018 and January 2019. 2017 and 2018 show the same. We see when the wind is blowing slightly from the east, we get elevated methane concentrations, and that's because there's a dairy farm in that direction. In January 2019, that's what we saw. And that was, the evidence was very, very clear. And the operator admitted that they'd released this methane in an uncontrolled way, and that's what the monitoring had detected. And just going back to the Vale of Pickering, because I've not mentioned that, I appreciate really at a time, is again, they didn't carry out hydraulic fracturing in the Vale of Pickering, but they got very, very close. They mobilised all of the equipment onto site, brought all the generators onto site, lots of truck movements, but never quite got the permission. So what you can see there is on the graphs is first bit, very low concentrations of, this is NOx, nitrogen oxides, low concentrations reflecting the usual baseline. When they brought all the vehicles onto site and tested all the generators and the pumps, very, very significant signal in NOx. And what that meant was that on the right there you can see, if you can see there's a very sharp blue peak, which is the profile you get for NOx at a rural, clean air site. The green is air quality you would normally see in a city area, London. And at KM8, at Kirby Miskerton, is not quite, it's not certainly not a city under normal conditions, and it's not pristine, so you get some emissions. But you can see when the operations started and the generators were brought into site, how that signature shifted for that period of time before it went back to baseline. I have to say that none of the concentrations here in the air quality parameters exceeded any air quality standards, but it just illustrates the fact that you have a concentration of industry, it leads to the changes in air quality and environmental parameters. And just finally, I think I want to just say that in terms of involvement, we couldn't have done a lot of this work without the support of the community. In fact, the industry itself and other local industries, but we participate, we've got the community to participate in what we're doing by organising drop-in events, asking them to volunteer to hold and have radon detectors in their houses, and also to be part of the process in terms of telling us what they thought about things, participating in these events, and giving us interviews so that we could learn what was really concerning them so that we could modify and improve the monitoring program. So again, we have web portals with all the information, the data on them, reports, and we undertook videos, and we've got videos of all the interviews, and also video descriptions of all of the monitoring activities we undertook. So just finally, in terms of meeting evidence needs, so I think one of the things we were able to achieve here is give the public reassurance that there was independent monitoring taking place. They didn't really know who to trust. So it's a case of building trust with the communities to actually demonstrate that they were being listened to and there was good monitoring taking place. We were taking our learning experience and sharing it with the industry, the regulator, to help them develop good practice, best practice, and some of the outputs, early outputs, certainly were informing the legislation, particularly in the Infrastructure Act, which was modified to reflect this new industry. And of course, the seismic events we monitored have led, I guess, in some ways to political decisions around the moratorium. So I guess I'll finish there, again, just a case study of how we addressed a particular monitoring need in relation to an emerging industry. Thank you.